All right. Hello. Welcome to another edition of Geometry. We are in Chapter 3. Section 3.1 is the first one, parallel lines and transversals. Our objective for this lesson is to name angle pairs formed by parallel lines and transversals. So a bunch of different angle pairs. The two different angles will have certain relationships based on parallel lines and transversals. Well, the easiest way to start is by what are parallel lines and what are transversals. So let's start with parallel lines first. You guys have probably heard of these before, but they're lines that do not intersect. And in fact, they're coplanar, so they've got to be on the same plane, and they do not intersect, so they never cross. Those would be parallel lines, like railroad tracks. And in fact, the symbol for parallel line is that. Okay, parallel planes, same basic deal. It's just two planes that do not intersect. And then skew lines, you're going to see this term skew, which is a different term for a different couple lines of relationship. But they're lines that do not intersect, but they're also not coplanar, and thus they're also not parallel. Okay, so they do not intersect, but they're not parallel. Well, how is that possible? Well, and that's where they're not coplanar comes in. Okay, if they're not on the same plane, then they're not going to cross, but they're definitely not parallel at that time. Skew line, it's almost better to see the examples. So we'll see that down here with our examples. Okay, first, identify the following, all of the following using the figure here to the right. So let's take a look at this. Letter A says all segments parallel to BC. Well, let's take a look at where BC is. BC is right here. So we need segments that are parallel to BC. So we could say FG over here, that would be parallel. It's not going to cross. It's on the same plane. So we'd say FG, segment FG. We can also say DA. DA is also parallel here. And then another one would be EH. EH back here technically would be a parallel line as well. Okay. Here comes our skew example for letter B. Letter B, which are a segment that is skew to EH. It just wants a segment, but we're going to give you a handful here. When we look at where EH is. So let's take a look at EH. EH is this back corner right here. So we're looking at skew. So we're looking for lines that they do not intersect, but they're not on the same plane. So for one example would be like BG down here. You can see BG is not going to cross, but it's also not parallel, right? You can tell what parallel lines are. So BG would be a skew line to EH. It's not going to cross it, but it's also not parallel. Another one would be like AB for the same deal. It's not going to touch line EH here. It's also not parallel. So line segment AB would be skew. And the same thing for like CF and DC. Okay, CF you can see is not going to cross. And same thing with DC here. Technically does not cross there as well. So all those would be skew. And then the last one here, a plane that's parallel to ABG. A plane that's parallel to ABG. All right, so let's make sure we get our plane set up and find that one, a plane parallel to ABG. Well, ABG is this bottom piece here. It's kind of the bottom of our box or our cube. So a plane that would be parallel to that would be plane EFC. Remember, we had to name planes by 3 letters. So I would say plane EFC. And you may have named it something different, but that would be this top plane here, which you just need 3 of those points. So you could have said EFC like I did, or you could have maybe said DEF or whatever. I'll just write it a little bit easier to see it a little bit more. A little better writing there. Okay? All right, and now what is a transversal? Okay, what is a transversal? Well, I'll give you the definition here. I'm just going to extend up. A transversal is a line that intersects 2 or more lines in a plane at different points. So it's going to intersect two or more lines in a plane at different points. So an example would be, like, say if we had this line here, let's call this line L, and then I'm not going to make them parallel. Let's just go with line M right here, okay? And technically it's cursive, right? So line M. And then a transversal would cut across both these. It would intersect two of these, so it would intersect both these lines. So let's say we just had, line P right here, and called that to be the transversal. So in this case, P would be your transversal through lines L and M. So it just intersects two or more lines at different points. You can see it intersects here and intersects here. It has to intersect at two different points to be a transversal. Okay? So there's a couple different things now with relationships between transversals and the angles. So let's just first talk about interior and exterior. Interior, kind of like angles and points inside the angles, it's going to be an angle inside the intersected lines or between the intersected lines. Okay? And exterior is going to be on the outside. It's going to be angles that are outside of the intersected lines. So that's interior and exterior. And now we've got a bunch of different relationships based on interior and exterior, but they're going to be consecutive or alternate. So you can see the table here is going to have a bunch of different relationships between consecutive interior and then consecutive interior, and then you'd have, say, alternate exterior, alternate interior, and corresponding angles. So those are relationships. So let's kind of talk about those. So the first thing is our angles here. What does it mean to be a consecutive interior angle? They're interior angles on the same side of the transversal. Interior angles on the same side of the transversal. So let's take a look at our diagram and first take a look at what our interior angles would be. Okay, so if we just think about interior, what we're really looking at here is these interior angles, because it's going to be inside the two lines of the transversal intersect. So it's inside those two. So 3, 4, 5, and 6, those are all of our interior angles. And so now which ones of them are consecutive? Okay, so consecutive would be they're on the same side of the transversal. So 4 and 5 would be consecutive because they're on the same side. And then another pair of consecutive angles would be 3 and 6 because they're on the same side of the transversal and they are interior. Okay? The next one, and just to point out again, T is your transversal here. Sometimes it helps just to make sure that you point that out, which one is the transversal, so that we know which one we're looking at. Okay, next would be the alternate exterior lines. So it's going to be something with angles, or alternate exterior angles. So it's going to be the angles that are outside of the two lines. So 1, 2, 7, and 8 would be exterior angles. But alternate exterior angles, they are exterior angles that are on the opposite sides of the transversal. So we're going to go on the opposite sides of the transversal. So we're talking exterior, but on alternate sides, on opposite sides of the transversal. So like angle 1 here would be an exterior angle, and its alternate angle would be this one down here. It's on the other side of transversal T, angle 7. So alternate means the opposite side, and exterior means it's outside of the two lines the transversal is crossing. Another set of those would be 2 and 8. Angle 2 and angle 8 would be another set of alternate exterior lines. They're exterior because they're outside of lines M and N, and they're alternate because they're on the opposite side of the transversal, so alternate exterior angles. Okay? Alternate interior angles. Alternate interior angles. I'll erase some of these here. So again, we're talking about interior angles. So again, we're focused on the interior, 3, 4, 5, and 6, basically. And now, just like the previous example, we're talking about alternate ones. So they're interior angles on opposite sides of the transversal. Sorry. interior angles on opposite sides of the transversal. So now we're going to take a look at these. So if we look at, say, angle 4, that would be an interior angle, and the alternate one to be its pair would be angle 6. So angle 4 and angle 6 would be alternate interior angles. And then furthermore, you could say 3 and 5 would also be alternate interior angles. Okay? The next one, the last one here, corresponding angles, this is the one that gives some people problems. It's basically one interior and one exterior on the same side of the transversal. And we kind of put in parentheses here, the same position. It looks like they're in the same position. Okay, so I'm going to just kind of erase this again. So you need one alternate and one exterior and one interior, and they're on the same side of the transversal. So and they kind of look like they're the same position. So we just take a look at angle 1. Angle 1 is above line M and to the left of the transversal. So which of these angles is also above a line and to the left of the transversal? Angle 5. You can see they're in the same position. They're above one of the lines and to the left of the transversal. So they would be corresponding angles. So you can kind of see the other ones as well. You can see that angle 2 would be corresponding with angle 6. They're above the lines and to the right of the transversal. Okay, we can keep going here and say that angle 4, what would correspond with angle 4? It's below one of the lines and to the left of the transversal. So the other one that's below and to the left would be angle 8. And finally, the last pair would be angle 3 and angle 7 because they're below the line and to the right of the transversal. Okay, so these are ones you're going to see a lot of, and you're just going to have to kind of figure them out as they go, but try to remember consecutive interior, alternate exterior, alternate interior, and corresponding angles. Okay, so let's take a look at this example here and try to identify each pair of angles. So when I look at this, again, it might help just to kind of locate what your interior angles are. So I go here, we've got our two lines, and this would be all the interior angles right here. These would be all your interior angles, all right? Because this line here would be your transversal. So sometimes it helps to just label that on the diagram in case you have more more lines involved in your picture. So that's a transversal. So we've got our interior angles highlighted. So 1 and 5, 1 and 5. We take a look at angle 1, and here's angle 5. What relationship do they have? Well, are they interior? No, they're not interior. So we know they're going to be exterior angles. And are they on the same side of the transversal or on the opposite sides? Well, they're on opposite sides. This one's above it, this one's below it. So we would say opposite means they are alternate, and they're exterior angles because they're not highlighted, they're not on the inside, so they would be alternate exterior angles. Alternate exterior angles. How about 6 and 7? 6 and 7. Well, we know they're interior angles because they're inside the two lines, and they're on the same side of the transversal. So we know they're interior angles. And are they alternate? No, they're not alternate because they're on the same side. So that one would be consecutive. And I'm giving you the abbreviations here. That would be a consecutive interior angles. How about 2 and 4? If we look at angle 2 and angle 4, here's angle 2, here's angle 4. Okay? What type of angles would these be? Well, we've got one interior and one exterior. So that should be a little tip right away. And they're on the same side of the transversal. So they are in the same position. They're above the transversal, but underneath the line. Above the transversal, but underneath the line. Over here, above the transversal, underneath the line that it crosses. So those would be corresponding angles. And finally, the last one is going to be angles 2 and 6. Angles 2 and 6. So if we look again at angle 2, I'll highlight that again for us so we know these are interior angles. All right, well, 2 and 6 are both in the highlighted region, so we know they're interior angles. But they're on opposite sides of the transversal. So the opposite means they're alternate, and then they are both interior. So the alternate interior angles. Okay, so hopefully we're seeing the relationships here. Okay, so same deal here on this example for numbers 5, 6, 7, and 8. I'm going to let you guys work on that on your own. Take a look at the lines and which one would be the transversal. In this case, just to let you know, line C here has to be your transversal because it crosses the other two lines. So use that to find your interior, exterior angles and what their relationships are. And the last one here, same deal. We're just going to kind of have you work on this also. I will give you a little tip. You got anything available from all previous lessons as well. So like number 9, angle 3 and angle 1 here, they're not any of the relationships we discussed today, but they are across from each other. Those would be vertical angles. So don't forget about vertical angles or adjacent angles in your with your relationships. Okay? For the rest of them, again, just to give you a hint, we'll go and give you that this is the transversal is line X here. And Y and Z would be the two lines that cross. So in order to give you the interior angles, I would say here's the transversal, and these angles here would technically be your interior angles. So that might help you out on that one because it's a little tricky. All right, so look at the relationships and what you got. So for example, 7 and 1 would be exterior angles, and they would be on opposite sides of the transversal, so they would be alternate exterior angles. So work on those on your own, and that's it for the section. Work on those on your own. Bring the questions you have with you, and we'll attack this the next time I see you. Okay? Thanks a bunch. See you next time.